We have here a pretty standard statistics and probability type problem for the Algebra 2 Regents. It says that Sean's team has a baseball game tomorrow. He pitches 50% of the games. Actually, what I'm going to do is I'm going to stop right there and start writing information down right away. He pitches 50% of the games, so that tells me that the probability of P, let's say, pitches is 0.5. And we continue. There's a 40% chance of rain during the game tomorrow. So I can write down that the probability of R for rain is going to be 0.4. Right, so. And then they say if the probability that it rains given that Sean pitches, now that's very important, that word right there shows up in these kinds of problems a lot. The probability that it rains given that Sean pitches it is 40, that means this. The probability of R given P, the probability that it rains given that P, the pitching, is already occurring, is also 0.4%. Okay, so all that said, what can be concluded that these two events are? Independent, mutually exclusive, dependent, or complements. Alright, so here's what would be helpful. Independent means that this is true. Let me write this down here. There's a formula that describes independent events, and it says that the probability of A and B, or A union B, as it should be called, in other words, the probability of A and B happening at the same time is going to be equal to the probability of A times the probability of B. And this formula holds as long as the situation being described is independent in nature. Well, we don't have things in terms of A and B, we have things in terms of P and R. So we want a formula that says the probability of P union R is equal to the probability of P times the probability of R. So what I'd like to be able to do is plug some values in here and see if the equation holds true. If it does, then we have independent events. Now what we have is P of R. We've got that. We have P of P. We've got that. But we do not exactly have the probability of P union R. We have the probability of R given P. Never fear. There's a formula that describes this thing called conditional probability. So conditional probability, and there is this formula that describes every situation that has conditional probability in it. It's the probability of B, event B, given that A has already occurred or is occurring. It's equal to the probability of A union B over the probability of A. And at this point, all you have to really do is pay very close attention to the order of things. I'm going to go ahead and write this out one more time like this. Instead of B, I'm putting R, and instead of A, I'm putting P, so that it lines up with the variables I've already listed. Probability of, let's see, probability of P union R over the probability of P. That, I should add, is the most important part. A is on the right side of the conditional statement, and it's in the denominator of the right side. P is on the right side of the conditional statement, and P is on the right side of the equation overall. Nailing down that order is really important, and it's the key to solving these kinds of problems. Anyway, now that I pointed that out, we can replace these variables and solve for this, and then I can use it to test this formula. So, probability of R given P, probability of rain given that we're pitching, is going to be 0.4. I don't know what happened there. 0.4. Probability of P union R is what I don't know, but I do know the probability of P. it's 0.5. Now we can multiply both sides by 0.5, 0.5, and we have solved for the probability of P union R. It's equal to 0.5 times 0.4 or 0.2. Alright, here's all we have to do now. Is this equation going to hold true? So, in place of probability of P union R, I'm going to place 0.2, just like I've solved for down here. In place of probability of P, I'm going to put 0.5. And in place of R, 0.4. And sure enough, that is going to be equal to 0.2. So, the formula that describes an independent event holds true, and that means that this situation is independent in nature, and 1 is the correct answer. Now that's the long, abstract, and mathematical way to prove to yourself that this situation is independent, or rather that these two events are independent. You could have also done this much quicker by simply knowing the definitions of each of these terms. Let me start from the bottom. So for complements, that's describing something along the lines of a heads or tails setup. In other words, there is only two options and their probabilities together add up to 1. In other words, it can only, in all of existence, only be either Sean pitching or it raining. But that's not the case. In fact, the probabilities don't add up to 1, they add up to 0.9, right? 0.5 plus 0.4. Seems that in this situation it could either rain, not rain, Sean could be pitching, and not pitching. So these events aren't complements because there are more than two options. Definitely not that one. Dependent. Okay, that's important. That means that one outcome affects another. This says, okay, does the fact that it rained have anything to do with the coach's decision to put Sean on the pitcher's mound? Doesn't seem like the problem is being described that way, so this problem is definitely not dependent in nature. Lastly, we think about whether these events are mutually exclusive, and that's a very particular kind of situation. Well, maybe not that particular. Can describe a heads or tails situation as well. Mutually exclusive means that, well, the events exclude one another. One event cannot happen in tandem with the other. So that says kind of like if you flip a coin and you get heads, that obviously means you cannot get tails. You can't have both at the same time. Now it seems pretty likely that it's possible for Sean to both be pitching and it be raining at the same time. In fact, there's a conditional probability here. It's actually fairly likely, 40% likely, that it will both be raining and that Sean will be pitching on the same day. Definitely not mutually exclusive. So from a reasoned perspective, independent can be the only answer to this problem.